I'm Andy Nesling, and I'm a software engineering manager at Dyson. I've been working in the Internet of Things area for about 14 years now. I started off at Nottingham University, so I did electrical and electronic engineering at Nottingham. After that, I worked on electric propulsion for large ships for a couple of years. Then after that, I moved into the Internet of Things area before it was called Internet of Things. So at that point, I was looking at automating the national grid. So I was doing that in the UK and then all around the world, out in Africa, Middle East, all the way out to Hong Kong. After that, I had a bit of a change of tack and moved into Internet of Things startup in Oxford, so doing electricity and gas monitoring, which I did for 3 years before joining Dyson, where I've been for about a year now. And I'm very, very passionate also about agile software development. So in the early part of my career, I was very used to waterfall development, large upfront spec. You've got a year to deliver it, and if you've missed something in the spec, you really get it at the end. But over the last few years, certainly, I've been moving into agile software development a lot more, and I've seen firsthand some of the benefits you can get from working that way. In that you can deliver an awful lot faster with an awful lot less stress. So a bit about the Dyson Connectivity team. So we are the fastest growing part of Dyson. We've got well over 100 software developers and designers now in the team. This photograph was taken about 6 months ago, and the team is now twice the size. We're split across 4 development centres. So we've got a development centre here in Bristol. We've got one just up the road in Malmesbury. We've then got one out in Singapore, and a new one we've just opened in Shanghai as well. And working within our team, we've got a range of experience. So we've got senior software engineers who've been working in software development for longer than they'd care to think about, through to graduate software engineers, interns, and now undergraduates as well. So we've just had people starting to do the university degree at Dyson, and they're actually working in our team as part of their degree as well. So, a little bit about our products, and then we can talk about why we want to connect them in the first place. So, the first connected product we launched was the robot vacuum cleaner, and we launched that about 2 years ago now. We launched it in Japan. It's got the most powerful suction of any robot vacuum cleaner, and it's also got quite an impressive 360-degree vision system with some very, very clever algorithms that run and actually allow the robot to navigate around your home and make sure it only cleans an area once. The second range of connected products we launched was a range of connected air purifiers. So those allow you to not only purify the air, but heat and cool the air as well. In terms of purification, it can get pollutants out of the air down to 0.1 microns, which, so a human hair the width of a human hair is about, I think, 500 times wider than 0.1 microns. Just gives you an idea about how small the stuff we can get out of the air is. So those are just a couple of the connected products that we've launched over the last couple of years. But we had a problem. So Dyson is very famous for producing excellent engineering products, but also, particularly with the vacuum cleaners, after you've gone around the house, you've spent a fair bit of time going around and vacuuming everything. At the end of it, you could actually see in the bin all of the muck that you'd sucked up, which was wonderful. You've got a bit of reward. This is how much better my house is now that not all of this stuff is on the carpet. But with the robot vacuum cleaner and the air purifier, we had a problem. How can we give people that moment where they actually understand? Oh, this is what the product's doing for me. And so that's really why we looked into connecting it. So first of all, with the robot vacuum cleaner, the most important thing for us in connecting it was it can't be a gimmick. It's a very important part of the culture at Dyson, in that good engineering stands on its own 2 feet. So actually connecting it can't just be we're connecting it because we can. It has to deliver some real value to our users. One of the important things with a robot that's going to go and clean your house is being able to set a schedule on it. Just saying, okay, I want you to go and clean the house when I'm not here. I want you to do it between these times. So that was quite an important feature for us. But then, if you do that, so if you do set a schedule, so the robot is going to go around and clean your house when you're not there, how do you know it has? When you leave in the morning, the robot is sat in the dock on the kitchen, and then when you come back home at the end of the day, it's still sat on the dock in the kitchen, and you don't know if it's cleaned your house or not. So one of the things we're very keen to do was actually give people some visualization to show them actually where has the robot been, what's it been doing. And so actually producing a map that we could show to the users and say, this is what your robot's been doing, was very important for us. And also, to get notified about when actually your robot is doing a clean. And after you spent a lot of years going around your house vacuuming and really getting to hate it, there is nothing better than actually being sat in a coffee shop and getting a message through to say, yeah, whilst you're out enjoying yourself, we've just cleaned your house. So we had a similar problem, I guess, you could say, with the purifier, and possibly even harder, because actually with the pollutants in the air, you can't, unless it's really, really bad, you can't see. And therefore, how can we demonstrate to people that actually the purifier has, in fact, made the air quality better in their house? So, first of all, we need to be able to schedule it so that actually it could just get on and sort it out when you're not there. But you needed some feedback in terms of what effect has it had? What effect has having this purifier in my house actually had? Also, we need the ability to quickly turn it on when you're not there. So you're at work or out and you have a quick look and say, actually, crikey, the air quality in my house is pretty appalling. I'd like it to be clean by the time I get home, so you can pop it on before you leave. But also, you want to understand, well, what effects is it having? How has the internal air quality in my house changed over time? And so, actually, starting to put together some trends that give people an idea about, well, when the purifier comes on, this is how the air quality changes over time. So, where are we now? So, we're now at a point where we've got hundreds of thousands of connected users. I think we've possibly got a company with one of the largest range of air measurement devices anywhere in the world now. We've got products now out in 30 countries around the world. We've got an increasing number of connected users, so not only is our user base growing, but the rate at which it's growing is increasing rapidly at the moment. And in order to keep up with all of that, we're having to open up development centres around the world to allow us to actually do development which is focused for the particular problems that we have in that market, which is one of the reasons why we've opened a development centre in Shanghai, where there's an awful lot of problems with air quality, and therefore actually having a group of engineers actually in that place means it's much easier to understand the problems that the people are having and how best to solve them. So, what's the future? What's the future hold for us? Well, we've seen that there's a tremendous number of advantages of actually connecting the products, and off the back of that, we want to connect a lot more of them. So, you can imagine almost any of our products actually having those connected allows us to collect data on how they're being used, allows us to actually understand how people are using them and therefore improve them over time. And soon there'll be an electric car too, and I'm sure there'll be a lot of connected features that we'll need from that. So Dyson at the moment are on a bit of a journey. So historically it's been a company who has been very used to making physical products and then shipping them out. As soon as you start also providing an online service to go with your product, you have to start actually thinking about what you're delivering differently. And in order to do that, we've started needing to marry this waterfall delivery approach where you've got, and you can't get away from it when you're actually shipping a physical product. When there's a physical product that's going to be shipped out the door, there's a certain number of features which absolutely have to be in that product in order that you can actually ship it out and people are delighted by it when they start using it. But because we've now got the ability to connect to the product remotely, we've got opportunities now to actually start improving the features of the product actually after we ship it. And that's something that we've never had the ability to do before. And in order to leverage that, we really need to be getting things out quickly and learning from actually what our users tell us when they're using it, and then actually improving the experience as we've got them out there. So in order to do that, we're thinking very carefully about what are the absolute requirements we must have at launch. So what are the things that we must get in there? Because the sooner we can get a product out, the sooner we can start learning how people are using it and how to make it better. But what are the things that we absolutely must have at launch? And then also, where do we put the user interface? If we actually embed the user interface on the product, it's much harder to change that then down the line. Whereas actually if the user interface to the product is in an app, for example, it's much easier to evolve that as we learn how our customers use our products. One of the techniques that we're using quite a lot at the moment is user story mapping. So this idea of actually understanding how a user will, right from the point of ordering to the product being delivered, getting it out of the box, configuring it and starting to use it, what are the key things that must happen in order for that journey to go well, and then what are the things that can extend that experience but that aren't necessarily required the second that you get the product out of the box. Now, in order to do all of this, and actually in order to be able to continue to extend the products after we ship them, we absolutely have to have the ability to be able to update the firmware or the embedded software after we ship them. And I'll mention this a couple of times today. If you've got the ability to update it, then you really can leverage the learning you get from actually putting it out there and gathering data on how people are using it. So one of the challenges that we've got is that Dyson is already a very well-known company around the world, and therefore when we bring a new product out, it's expected that actually we will launch that pretty much around the world all at the same time. So we haven't got the ability, for example, just to launch in the UK, learn what that means, get some problems sorted, and then launch it out globally. When we launch a product, chances are we're launching it around the world all at the same time. So that brings its own challenges. So one of them is that it's certainly in some countries, actually, it's pretty hard to get a reliable internet connection into or out of that country. And actually, if you want to give the people in that country a great experience, you actually need to have your service hosted in that country as well. So certainly we're having to overcome some of those problems at the moment and actually bring up in certain places an entirely new cloud infrastructure actually in the country to ensure that people in that country are getting the best experience possible. We also have to think about user experience. So the user experience, how somebody gets value from the product in the UK could be quite different than in Japan, for example. And it's not just a matter of just changing the language on the app. You have to think about a lot of different things. And in order for us to do that well, one of the things that we are leveraging a lot actually is using the people who are actually in the country to give us feedback. So the engineers and the customer support teams that we've got in the country is getting it in front of them early so we can actually get feedback from what are the particular problems in this country and are we solving those? And it's very hard if you're doing the design in the UK to try and understand how in every single market around the world is it going to be used, and what's the really important thing for people there. So, when you start connecting products, one of the first things you have to consider is, well, where should we actually put the logic? And what features have to be connected? Now, this is something that, for example, manufacturers of internet-connected thermostats have to consider quite a lot. If the internet goes down, you still want the heating to come on, you still want your house to be warm. And therefore, there's a certain amount of logic which you have to embed in the product so that regardless of whether you've got an internet connection or not, actually your house is still going to be heated and it's still going to be warm. So you've got opportunities to put the logic actually down in the machine in somebody's home, or you can keep some of that logic in the cloud. But regardless of actually where you put the logic, you always need to be able to update it. So, implications of actually putting the logic down in the machine itself. One of the advantages is that actually it's robust. It's robust and fault tolerant. If the internet goes down or if it's slow, actually the product is going to continue working exactly how the user is expecting. It's fast as well, so particularly if you were connecting over a mobile network, you're going to get quite a lagging experience compared to actually if that particular feature was implemented purely in the product itself. The downside though is that it's hard to change. Even though you have got the ability to update something
over the air, it's a reasonably involved process to actually get that working reliably and ensure you can actually roll that out to your entire field population, and it will take some time to do that. And you also have to consider backwards compatibility. So if you've embedded some logic actually in a machine and you then update it, all of a sudden now your cloud and your apps that communicate to those products have to cope with two different implementations, and that problem just gets worse and worse and worse. Whereas if you actually put that logic in the cloud or in the app, for example, you can then update the behaviour for your entire population of devices all in one go. But if you do that, it can be slower. It can be much harder to make it fault tolerant, because there's an awful lot of other moving parts that are going to affect what your product does. The advantage is, though, it's easier to change. And you also have to then think about what's actually going to scale. So I've got an opportunity now. I can embed some logic in this robot vacuum cleaner, or I can keep that logic actually in the cloud and use that to tell the robot vacuum cleaner what to do. Now, and you may think, okay, let's put that in the cloud, because actually I want to be able to change. I'm not quite sure what feature I want yet, and I want to be able to change that quickly. But then one thing you have to consider is, okay, as that starts to scale, so as I get hundreds of thousands of devices needing that, or even millions, actually it's now quite costly to actually perform that logic in the cloud. I've got to spin up quite a few servers in the cloud in order to cope with that feature. Whereas actually the cost maybe of embedding that feature in the device is almost nothing. So scheduling is one of those examples actually where we've looked at a couple of different ways of doing it. So with scheduling, for our air purifiers, we've actually stored the schedule down in the purifier itself. So we set a schedule, we download it to the purifier, and then we let it do its thing. For our robot vacuum cleaners, actually, we're holding all of the scheduling in the cloud, and we actually tell the robot vacuum cleaner when we want it to start and when we want it to stop. There are advantages and disadvantages of both ways of doing it, but regardless of which way you do it, it's very important, particularly for anything time-based, to make sure that everything is communicating with UTC, so that your robot or your air purifier, everything it knows and the way that it communicates the scheduling information up to the cloud and to the mobile app is UTC. The mobile app, everything is set in UTC. In the cloud, everything is set in UTC. You need to bring the user's time zone into it so that the product is starting and stopping at the right time. But actually, if you start to use local time zones and you're passing local time zone information between all the products, you very, very quickly go mad and it gets into a horrendous mess. So we've tried both ways. And we're actually now heading towards one particular way of doing it. Given a choice, if you could choose, actually, for scheduling, whether to put the logic actually in the product itself or whether to put it in the cloud, which one would you do? Who would put it in the product? Who would put it in the cloud? Pretty much half and half, and we were in a very similar place. So we genuinely couldn't decide, and actually we tried it one way and tried it the other. What we found, and the way that we're tending towards, is actually we're better off putting it in the product, because of that robustness, the fact you don't have to have an internet connection in order for the product to actually do what you need it to do. We find that the advantages of that outweigh the disadvantages of having to change that by possibly doing an over-the-air update. So we've decided where we're going to put the logic, but then we actually need to control the product remotely. So particularly once you start to get a very, very large number of devices, real-time control gets quite hard, because with real-time control, people are expecting it to happen instantly. So one of the things that we have to consider is, well, actually, what features do actually need to be real-time? Because actually doing things in real-time can be quite costly. and therefore, for example, that actually if I want to turn my purifier on from my app, that needs to happen straight away. I'm in the same room as the product. When I switch it on, it needs to turn on straight away. But actually, for example, a notification from the product to say, I've just finished vacuuming your home, that doesn't necessarily need to come out the second that the product finishes. And actually, you can probably queue those messages up and then process them possibly over a minute or something like that. But you've not got to cope with a very, very high peak load. Whatever you do though, and what we're thinking about a lot is in terms of deciding whether something needs to be real time or whether it can be slightly slower than real time, is what's the user going to perceive? What in terms of consistency? If I'm in the same place as my device and I'm asking it to do something, I'm going to be expecting it to do it straight away. Whereas some of the features, for example, like notifications, where I'm most likely not in the same place as my device, if that's a little bit laggy, it's not going to impact the user experience. And also with real-time control, if you need to persist information, that then slows it down. So you have to consider, are there things actually that we can get away without persisting? Because if we don't have to persist that state, then actually the problem becomes a bit easier. Now, interestingly, some of these problems may start to go away soon. Certainly with a growing use of service architectures, things like AWS Lambda and Azure Functions. Actually now, you haven't necessarily got to provision all of the infrastructure that you need to be able to cope with the peak number of people doing something at one particular point in time. Because you've actually got the option now, literally, to spin something up, to process the request, and then literally to be killed off again. So actually, that's starting to possibly give you a few more options now that maybe you wouldn't have had a couple of years ago. So, server load from IoT devices. What's the good and the bad? The good thing is that it's actually predictable. With a whole heap of Internet of Things devices, you know that given a particular population of devices, that actually they're going to be doing the same thing every time. You know what software is in them, and you know actually I've got hundreds of thousands of them, but actually they're always going to be doing the same thing at the same time, and therefore actually you can predict what that is and you can simulate that in advance. The other advantage you've got is actually you can only make them so fast. So you know in advance how many you're going to have, and therefore it actually makes simulating that up front a fair bit easier. The disadvantage is though that actually they're time synchronized. If you don't do anything about it, for example, our air purifiers send us every hour. This is the information that we've measured this hour, and if we did nothing else about it, every hour we would get hundreds of thousands of devices telling us some information that second, which is actually pretty hard to cope with. The other disadvantage of Internet of Things devices is that they don't give up. Unlike users, so if your website is slow and you're struggling to cope with the load, actually, chances are somebody will see, oh, actually this site's being slow at the moment, I'll come back later. And so generally the load tends to drop off a bit. With Internet of Things devices, they don't care if you're struggling. They literally just keep hitting you and hitting you and hitting you. So, what can you do about that? The first thing is just to consider the data rates, consider what you're sending. Although I can send all this information up, do I actually need to? What is the critical stuff I need to send up? The next one is that actually you want to unsynchronize the messages, so you don't want your entire field population telling you something at exactly the same time. You want to spread that out, and also if you do get to a point where actually there's just too much load and you just can't cope with it, you want those devices to back off. So actually I'm too busy now, and they'll back off and they'll say, okay, I'll come back in 10 seconds. Still too busy. Okay, I'll come back in 30 seconds. And that back off, you want that to be random as well, so that actually you don't get every device literally backs off for 10 seconds and they all hit you again 10 seconds later. It's also very important to think about actually recovering from a failure. So what we see, it's very interesting, we've got such a large number of devices out there now, that quite often we will see in what we monitor that there's been a glitch, for example, in the network connectivity for a particular ISP, and we'll see several, well, certainly 50 or so thousand devices literally disconnect and then come back on again a few seconds later. And you've got to anticipate that it's not just that actually as people install the product, and we know how often people are going to be installing the product, and therefore we can predict, okay, well, we're going to get this sort of load over time. You have to think about, well, actually, when things don't go well, chances are actually everything could come off and then come back straight on again at the same time. And you have to be looking to simulate that. Queuing again, if at all possible, you want to be able to queue stuff so that actually you can process that in slightly slower time, allows you to bring things up a bit more gracefully. Then another interesting one is actually if some of the products start behaving badly, you want to be able to blacklist them. So you don't want to, if a product or a range of products suddenly starts talking to you very, very fast, you need to be able to actually just stop listening to those. But when you do, you need to be able to stop listening very, very early on. Actually, if it takes you quite a lot of processing power to actually talk to the device, understand, is this one I should be talking to? No, go away. If that's actually been quite intensive for you to do, even literally just kicking them off, you actually won't be able to cope. So, automation, this is one of the things that can help. So, we do a lot of load testing because that load from all of the purifiers and the robots, when that comes to us, if we can't cope, they're just going to keep on trying, and therefore we have to know in advance that we're going to be able to cope with that load. So we do a fair bit of automated load testing in order to give us some confidence that when the products go out, we'll be able to cope with the load that's coming from them. One of the things that we're doing a lot now, which is wonderful, is using the likes of Amazon to be able to actually spin up a whole simulation of our field population, so that actually we will hit a representative environment that's similar, exactly the same size as our production environment, with the load that we will see from up to 1 million products, and actually validating that yes, we can cope with that load. And once we've done that test, we just turn all the instances off, and we're not paying for them. That is something that you probably, a few years ago, you wouldn't have been able to do, and actually would have made load testing very, very hard, because you'd have to purchase physical hardware in order to be able to do that. So it's actually made simulating this sort of stuff a fair bit easier now. Another thing that we do an awful lot is make sure that the metrics that we use when we're load testing are the same metrics that we use actually when the system is running in production. The reason being is when we're load testing, if we have a problem and we haven't spotted that in the metrics, we're going to have, if we have that same problem in production, again, we're not going to spot it. The other advantage of using the same metrics to load testing and in production is actually, load testing is still a simulation. You're estimating what the load is going to look like from your field population, but actually, until you have that load, you don't genuinely know. Whereas if you've been using the same metrics in your load testing, when your production gets up to that load, you can actually compare the two and say, actually, was my simulation reasonable? Or do I need to tweak it? Because actually I need to do a simulation for 2 million now, and I need to make sure that the simulation is reasonably accurate. Another thing which you learn when it bites you is that you need to also monitor the clients. So the clients that you're using to simulate that load, you may think that actually, yeah, from a particular instance, I'm simulating 50,000 devices, and my system is coping very well. But actually, the client I was using to simulate that 50,000 devices actually is maxed out, and it's not putting anywhere near the sort of traffic on that you were expecting. So it's very important when load testing to make sure the clients you're using to simulate the load are actually working as you expect. And again, back to the point earlier, is you need to simulate not just a steady state. So you need to simulate the problems where actually the whole thing has come off and gone on again, and can I cope with that? So what levels do we automate at? So we're doing an awful lot of unit testing, obviously, but then acceptance testing for our subsystems.
Oh, do you want this wall up?
That's fine, thanks. Yeah, cheers. So, unless you want them all up, we can put them all up. So, we're now looking at acceptance testing our subsystems. So, for example, we will acceptance test our mobile app With the products and the cloud mocked out, we will do the same thing for the products and for the cloud. We will acceptance test individual services with their dependencies mocked out. We will then look to do some contract testing of the interfaces between each of these things. So actually, we've tested an app with the cloud mocked out. So we've got a simulation of the cloud, we've got a simulation of the product, and we've used that to test our mobile app and exercise all the functions of that in an automated fashion. But we now need to make sure that actually, if the way that the mobile app communicates to the cloud changes, we need to know about that, because actually we've mocked those two things out. So if the cloud starts behaving differently, and the way that I've mocked the cloud changes, I need to know about that. And so that's where contract testing comes in, actually validating that the contract, the language that these things are going to be using to communicate with, isn't changing. So in our example, we've got a cloud with many services in. Each one of those has been tested independently. We've got a mobile app, we've got a product, and we've tested the contracts between each one of those. So if any one of those changes, is that all we need to do? Is that good enough? If we've tested each bit in isolation and we've tested the links between the bits, is that a good enough test? What do you think? Is there anything? What's missing? If that's not a good enough test. Integration, absolutely. So the last bit of testing that we do is actually testing the thing as a whole, to make sure that actually when we plumb all of these bits together, they do actually work as required. Now actually with integration testing, or smoke testing, generally speaking, the sort of automated tests that you're doing there can be really quite brittle, because actually there's an awful lot of moving parts that all have to work in order for your test to work. And so it's very important that you actually haven't got a lot of those. You've literally just got one or two that actually run through all the main parts of your system and prove that, yes, actually they do all work together. You're not looking to exercise every single feature with everything pulled together. It's literally just key journeys through that actually prove that, yes, you know what, when I put it all together, the fact that I've tested the bits in isolation, I've tested the way they communicate, actually when I do put them all together, the whole thing does work. Another thing that we're starting to do an awful lot more of now is also automate the deployments, so that actually we can spin up a representative environment literally now within an hour, where previously it would have taken us probably a couple of weeks to bring up a representative environment that was similar to our production environment that we can test in. And the only way that you can do that and do that reliably is by actually automating the deployment, so that literally there's no manual intervention needed to bring up an entire application stack. So you've got your system up and running. What should you monitor? Basically, it's everything all of the time. If it's moving, if it's changing, monitor it. If it doesn't move, monitor it in case it does change. So we invest an awful lot of time in making sure that we're pulling back not only information on memory, CPU, disk space, network usage, but also key important metrics about how the system is performing. How many maps have I generated today? How many people have logged in? How long did it take those people to log in? And actually getting all of those metrics into the same system that is giving us information about memory, disk usage, CPU usage, etc. Because actually, if you pull all of that information together, you can very, very quickly get to actually what's causing the problem. So user registration is slow, but actually, the CPU usage on the provisioning system is high, and very quickly you can find out actually what's causing this user behaviour problem. Another thing you can do is, when you've got a whole population of Internet of Things devices out there, is also to actually monitor those, and monitor them just like a fleet of servers. There's an awful lot of properties of those that actually you can monitor in terms of which version of software they're running, how they're performing. And all of those things are critical to you in terms of how your system as a whole behaves. So we're also investing a lot of time in making sure that actually we're monitoring the health of all of our devices just the same way that we're monitoring the health of our servers. And the last thing is, we can set up alerts for all of this, so we can set up alerts to say, well actually, when CPU usage gets to 80%, actually I need to know about that because I'm going to need to do something about it. But it's actually also very important to trend those things over time, because chances are, if you're trending it and you're looking at this information over time, you will see before you get hit by the problem that it's coming. You will see over time that memory usage is ramping up. And actually you've got the opportunity then to do something about it in slower time, rather than actually there's now an alert and I need to do something about it immediately. So one of the things that we're learning is that, unsurprisingly, people don't scale like servers. So I'm now got a team of 30 software engineers, testers and infrastructure engineers. When I joined Dyson about a year ago, I had 3, and so it's been very rapid growth to get from 3 people up to now 30 people, and some of the things that we've learned in order to do that well it's very important actually to give a team a particular area of responsibility and give them autonomy to be able to make the changes that they need to actually get that thing out to production, but also that they're responsible for that thing running in production. So, I mean, there's potential if you have lots and lots of small teams, all of them have got autonomy, that actually the whole thing doesn't gel together. But actually, if the team feels ownership of the service that they're working on, and they're responsible for supporting it in production, if you know that actually if there's a problem with it, you're going to be woken up at 3 o'clock to sort it out, actually you do invest that bit of extra time to make sure that you're happy with the test coverage before you put that feature out. Another thing is aiming for consistency, but when it matters, and this is something that we're juggling at the moment, trying to decide. Okay, it's very important that each team has got autonomy to make the changes to allow them to be able to move fast and get those changes out. But actually, if every single team is doing things completely differently, we don't leverage the fact that actually that problem might have already been solved before, and that actually all of the teams actually have got that problem. That there's a problem with automated testing. And one team's built a great framework to actually allow that testing to happen. Now, if every single team has done things completely differently using different languages, it's harder for you to leverage something that has actually already been solved by somebody else. So we're literally juggling this at the moment, trying to decide how much consistency should we aim for in order that our teams have got autonomy, that they can move fast, but actually that they can also leverage the learning from the other teams as well. And the last thing is you've got to be aware of Conway's law. Has anybody heard of Conway's law? It's a very interesting one. So this is a law from a software developer back in 1967, but actually it holds true today just as it did in 1967. And it's that organisations which design systems are constrained to produce designs which are copies of the communication structures of these organisations. Now, this is really a very interesting one, and I think the reason that it holds true now, just as it did in 1967, is because actually it's a behaviour of people, not a behaviour of systems. If you've got 2 teams, and there's a particular problem that they need to solve, but let's say one of the teams is in Singapore, one of the teams in the UK, and actually to solve that problem, actually it's better. So the team in the UK have got a problem that needs solving. The right place architecturally to solve it is to ask the team in Singapore to make that change. But actually it's hard because they're in a different time zone and actually want to move fast. And therefore, actually, the team in the UK, for example, make that change not in the ideal way, but so they do something which isn't ideal, but actually it's allowed them to deliver it. And so you have to be very, very conscious of this, that actually, as you get many, many teams, you have to be very careful about how those teams are communicating, because the fact that they can't communicate will mean that actually the architecture of your system is defined by actually how you've arranged your teams. Now, you can occasionally use this to your advantage. If you've got two systems and you want a very clearly defined API between those two systems, maybe you want to expose it externally to somebody as well, then have one team look after the provider of that service and another team look after consuming that. And that will naturally, because those teams are separate, lead to a very clearly defined interface between those things. But it's certainly something, as the teams start to grow, you have to be very aware of, that actually, if this team's not talking, that's actually going to impact our architecture. And the other thing you notice is that as your teams grow, when there was a team of 5 or 6 people, actually in the morning everybody would get together, have a chat, talk about what they were doing, everybody understand what everybody else is doing. The second that you've got to 30 people split across 4 time zones, literally those conversations don't happen anymore. And you have to try very, very hard to make sure that when important, that actually each of those teams are talking. So, remaining backwards compatible is a particular problem with Internet of Things devices. So, one thing you have to consider is that the firmware which you put onto your products when you first ship them out the door is basically, you're going to have to cope with that forever. So the very first firmware that you ship out with your products, you're always going to have to be able to talk to those, because actually some of them may go into a warehouse and actually they get shipped out to the user for a couple of years. So eventually somebody installs it, and when they install it, they're going to expect it to work. And so actually, the firmware that you ship out, you always have to be able to communicate with. It may be the very first thing you do is update it, but you always have to be able to communicate to that particular version of software in order that you can update it. And so you have to think very carefully, actually, before you ship something out, that when we do this, we need to make sure that we can always talk to that. So very quickly you get to this place where you've got loads and loads of different versions of software running on your products. You very quickly get to the same place where you've got lots of different versions of your Android and iOS apps running. And actually, you've got a number of microservices that actually, because you want zero downtime, are running different versions at the same time as well. And all of these things literally have to work together. Now, if you were to actually test each of those combinations, very quickly you just get to a point where you'd literally just be doing nothing apart from testing and never releasing anything. And so actually, this is where, for example, testing the contracts that each of the parts of your system is going to use to communicate with is really, really important, because actually if you can validate the contract hasn't changed, then you don't need to test every single permutation of all the different parts. And lastly, it can be tempting to say, actually, you know what, well, this problem's going to be easier if actually we release this version of firmware at the same time that we release the mobile app and change to a cloud service. And therefore we don't have to cope with that complexity. But literally it never works. So, because something gets delayed, each one of these things it actually has got completely different release cadence. It may be that you're updating the software in your product every few months. It may be you're updating your mobile app every couple of weeks. It may be you're updating a cloud service every couple of days. And so it's very quickly, if you try and tie those releases together, you very, very quickly get into a place where actually you're slowing all of your development down to the pace at which the slowest part of your system is being released. So, security in an IoT world is not straightforward, but certainly what we've learned is don't do anything special. If you're doing something special from a security perspective, then it's going to break. Because there are an awful lot of people, much cleverer than you, who will be able to actually break that thing. So you're far, far better off actually following the well-trodden path. The other thing that we do quite a lot of now is actually embed security experts within our development teams. So it's not something that literally, just before we're about to ship it out the door, we'll run a quick penetration test and make sure that we haven't missed anything. We actually get security engineers and architects working within our development teams to make sure we're actually embedding that in right from the beginning. And it's very important not just to test the server. It's just as important to test the security of your device as it is to test your server. Because chances are, if you don't, then somebody can take control of your devices and then start using that to do a denial of service attack on somebody, or even worse, actually on yourself. So we're starting to gather an awful lot of data now, and now at the point where actually we've got billions of anonymized data points, and there's an awful lot of information in there which can help us actually learn how our customers are using the products and making them better. But in order to actually leverage all of that data, one of the very first things that we need to do is actually get that data off our production system and get it onto a system which is actually designed to cope with an awful lot of things hitting it to try and understand and answer a particular problem. If I try and do that analysis with the data actually on my production system, all I'm going to do is slow my production system down for all the users. So one of the first things we do is get that data off production and put it into a data warehouse which was specifically designed for that job. The next thing is actually, wherever possible, try and get all the data into one system. So try and get the information about what your users are doing into the same system that you've got all the information about what your products are doing. Because then you can start to answer some really, really interesting questions if you can pull all of that information together. And then when you've got specific questions to ask, that's when you can really use machine learning to then really start to get some very, very interesting information out. So how are we using the data? We're using it to better understand how our customers use their products. And the really nice thing is now that our innovation doesn't stop when we ship a product. That, in some ways, that's actually now where our innovation starts. The second we can get that product out in front of our users, we can start learning from how our users are using it. Then, with all of that data, that actually allows us to build much better products, because we're seeing literally how people are using it. We're learning from that, and we're able to iterate quickly and deliver better solutions for people. But only because we've got the ability to update the software and the devices. So, wrap up. So what are we learning? So we're always learning that we have to ensure that connectivity extends the product. Literally, we can't connect a product just because that will mean that we can get some useful information from it. It has to bring real value to people. Otherwise, literally, it just won't be connected, and we won't be able to get that data. We have to consider what's required at launch. So what are the essential features that we have to have in as we ship that product out the door? Literally invest in automation. If we hadn't got to the point where actually we've got the ability to automatically test each of our components of our system, we very quickly got into a place where literally we wouldn't be able to release anything. And using the data to continuously improve our products. So we're hiring. We're hiring in Bristol, we're hiring in Malmesbury, out in Singapore and Shanghai. So if you're keen to come have your lunch underneath the Lightning Jet, then have a chat with either myself or Emma after. We've got a range of options open, from internships to graduate positions, and in a wealth of areas in software engineering and electronics, etc. Cool. Any questions?
So in a lot of your products, I guess, because they're quite big, you have the luxury of being able to put a full application processor in with quite a lot of RAM. But are you thinking about any much smaller products like sensor type things, and how is that going to change the kind of logic that you decide to put on the device and in the cloud?
No, great question. So at the moment, actually on some of our products, we really haven't got much processing power at all. And therefore we're having to actually think very carefully about, well, actually ideally we would put that in the product, but actually at the moment the only option we've got is to keep that logic in the cloud. The nice thing is that the cost of processors is going down all the time, and therefore you're getting more and more opportunity to actually put more logic in the device. And certainly some of the tools that, for example, Amazon are bringing out now, the ability to, they're sort of blurring the line about where your logic can sit. So almost actually some of your cloud logic now can actually sit down in the device, and actually it's just as easy to update it as though you were updating the logic in the cloud. So interestingly, with the advances that we're getting in cloud computing and actually the cost of processing coming down, it's giving us a lot more options now about actually where we can do those sort of things.
You said that you always have to be able to support older versions of their software. So do you still continuously run automated tests against those older, let's say, deprecated versions?
Yeah, great question. So we have some. I mean, what we do a lot more of is making sure that actually the communication contract, which those old products adhere to, that we haven't broken those contracts. So we do a lot more of that sort of testing, rather than, for example, spinning up a whole farm of devices running different versions. Is making sure where we've changed the communication contracts in specific versions that we're actually compatible with those particular contracts. So actually, it means it reduces the amount of testing we need to do.
If you buy a product which relies on the cloud access, how long do you support those products going forward into the future?
That's a great question. That's a great question. So at the moment, we haven't put a limitation on that. We haven't said that actually we will stop supporting that product at this particular point in time. So at the moment, we're supporting everything. Was there anything you wanted to hear today about what we're doing at Dyson which I haven't covered?
What's the car? How's that?
Yeah, I don't know. I genuinely don't know. So one of the things that we're very careful with at Dyson is actually people working on a specific project, generally speaking, don't get to see information from people working on different projects. So actually, if you're not working on the car, then chances are you're going to not see much information about that. So I'm not in that team, so I genuinely don't know.
Is that being worked on in Bristol?
That's being worked on in Malmesbury. Yeah, at the moment. But the development we're doing in Bristol is growing all of the time. We've already got to the point where we've outgrown the existing place that we are in Bristol, and we're going to be moving to somewhere much bigger early next year.
Just a little bit about the technology stack. Like, what would you use?
Sure. So from the cloud side, it's a mixture of Java, C#, and Node.js. On mobile apps, so iOS is now moving to Swift. Android is currently Java. On the products, it's primarily C++. Down the products. Yeah.
Do you have any examples of where you've used the data that you captured to improve your product and service?
I do, but not. I'm afraid that I can. I can give you at the moment. I think probably that we're going to be talking a lot more about that in the future. I guess what I can say is that the way that we're using that data at the moment is to make sure that actually we're using it to make the products better. So we're not selling that information off to a third party or anything like that. We're literally using that data so that actually we can make those products much better. And actually, because we're now gathering a lot of that data, we're starting to look at actually what sort of learning can our systems do when we put them out there. So that actually they autonomously learn actually how to, for example, how to purify the air better. Lovely. So, literally, if you've got any more questions, I'm going to be around for a bit. So is Emma as well. So if you want to understand what we're doing at Dyson, what the opportunities are, please come and grab us. And thanks very much for giving me the opportunity to come and have a chat with you.